Johnson, the Minnesota professor who first predicted how many illnesses expect strains would cause and how much they would cost, had an unusual perspective on the problem. He treats infectious diseases at Minneapolis's VA hospital, where most of the patients are men, and most are also much older than the students Mangy's had studied. His patients, too, had UTIs, though for different reasons than women did, from an enlarged prostate that kept a man's bladder from emptying or from an immune system faltering from age. They also had expect infections elsewhere in their bodies, proof that the resistant E. coli problem was more widespread and more complex than illnesses only in young women. Johnson had a long research interest in E. coli. He had helped Mangy's and her Berkeley advisor, Lee W. Riley, analyze the first resistant strains she had found, and he had shared their sense that the problem resembled a foodborne outbreak. But almost no data existed to back up that intuition. Though the multi-agency federal NARMS project had been established 3 years before the Berkeley outbreak began, its nationwide searches looked for only one E. coli strain, the toxin-making 0157H7 variety, and not the newly recognized XPEX. If Johnson wanted to define their incidence, he would have to gather his own data. Fortunately, a model existed to illustrate how to do that. The investigation that Smith and Osterholm had just carried out at the Minnesota Health Department, not far from Johnson's office. Since Cipro was a crucial alternative drug in UTI treatment, Johnson decided to research whether the fluoroquinolone resistance that Smith and Osterholm had documented in Campylobacter on chicken was also appearing in E. coli. He compiled a list of grocery stores around Minneapolis, 24 stores, independents, and members of national and local chains, in 17 cities and towns. Every 2 weeks between April and December 2000, he and colleagues from the Minnesota Department of Agriculture randomly selected stores and bought 10 packages of pre-cut chicken from whichever brands were sold at those locations. They did that for 7 months, accumulating 169 packages to analyze. When they found E. coli, they analyzed it for quinolone resistance and then sorted the resistant ones to determine their type. Benign commensals, diarrhea-producing foodborne illness strains, or XPEX with their unique genes for attachment and virulence. They found even more resistant XPEX than they had anticipated. 2/5 of all the E. coli strains they found in the chicken packages were resistant to quinolones, and 1 out of every 5 resistant strains was an XPEC. In other words, almost 10% of grocery store chicken was carrying E. coli that could cause the newly recognized severe infections, and was resistant to one of the main drugs used to cure it. The results showed that Mangy's and Johnson were on the right track. In these chicken samples, resistant XPEX were a foodborne organism. But there would have to be much more work to confirm the link between food and XPEC infection. In 2005, Johnson and his collaborators reported that they analyzed 346 samples of food that they bought around the Twin Cities during the course of a year. Beef, pork, chicken, turkey, and produce, to see which were most likely to carry XPEX and whether the strains were resistant. They found 12 resistant strains, all on turkey, possessing defenses against 10 different human-use antibiotics. 4 of the 10 XPEX that they found on the turkey samples matched E. coli strains that were already known to infect humans. In a second study published that same year, they scrutinized 1,648 food samples, including 195 that were chicken and turkey. Simply assessing which food type carried E. coli, one of the first steps in their analysis, began defining the problem. Only 9% of fruits, vegetables, and seafood carried the organism, but 69% of beef and pork did, and 92% of the chicken and turkey. As a second step, they asked which of the E. coli strains they had found were resistant. Those were most likely to come from the poultry samples. Some of them were multi-drug resistant to as many as 5 separate classes of antibiotics. In their third step, they examined the resistant E. coli they had identified, looking again for the molecular evidence of XPEC. Compared to other meats, poultry was twice as likely to carry XPEC strains. To determine whether poultry was transmitting those strains to eaters, the team recruited the cooperation of 4 hospitals in towns near the Twin Cities. They asked 622 patients in the hospitals to donate samples of their feces immediately after being admitted, because what was in their intestines at that point would have been carried in from the outside world. At the same time, they bought even more meat, 40 packages of chicken in each of the 4 towns over the course of a year, as well as 40 chickens bought directly from farmers who raised their birds without antibiotics. They identified E. coli strains on the chicken meat, sorted out which of them were resistant, and separated out the XPEX from other resistant strains. They retrieved resistant E. coli from the patient's fecal samples as well.